this demo, we will show an attacker trying to perform an account takeover attack using different tools. They will start with a browser and a login page attempt. Once that fails, they will continue by trying to exploit a vulnerability within the API layer of the application, followed by an attack via a mobile device emulator using the mobile application of the website. We will use the single stack approach to protect against all of the attacker's sophisticated attempts, and eventually see how everything comes together with the unified view of attack analytics. To begin, our attacker has either stolen or purchased a list of email addresses and passwords. This list represents those different user credentials. Our attacker will run an automated script that will pull these details one after another in an attempt to log into the web page. However, their attempts will fail as our customer is using Imperva to protect their websites. Within our Imperva dashboard, we can see that the number of account takeover attacks has increased, but all of those attacks have been terminated and blocked. The security team can click into the Incidents tab to discover in more detail the reasons and explanation behind each blocked attempt. As we can see in this example, multiple attacks were launched from different source IPs and locations, confirming a very complex and distributed attack, blocked in its entirety. However, this has not swayed our attacker, who by now has acknowledged their failed attempts, so executes a new attack to try and exploit the API layer supporting the web application. By going directly to the API, the attacker can try to trick the library that handles the authentication by sending the multiple email addresses and passwords via an automated script. As we see, the attacker is now attempting to run their script directed at the API layer using this batch file to target and attack the API, but again with no success. Back in our Attack Analytics dashboard, we see and can confirm that all of the attacks were blocked and tied to an API violation. When clicking into this specific incident, we have increased visibility and observe that almost 1,000 events were blocked. This specific attack mirrors similar activity that we observed with the account takeover attack. But we see here that every attack was blocked because of an API violation. Further down, just like the account takeover attack, we too can confirm a wide-ranging attack and at what time the attack took place. We now know there were a multitude of attacks blocked as identified within Attack Analytics. However, our API security dashboard can provide even greater context with regards to the endpoints. We know the attacker was trying different login details, so we'll go a bit deeper into this. Now, the same API violation that was flagged within Attack Analytics and blocked can be explored in greater detail. Within this event, we can uncover the exact reason this attack was blocked. What we observed is that the event was blocked due to a missing parameter, meaning the attacker was trying to send partial bits of login information to the API layer, violating the Swagger structure. Lastly, our attacker will try and attempt an attack using the mobile application by recording a valid login and capturing it with Wireshark, a network capturing tool. Because of this, the attacker is now able to see what parameters are being used that represent a real and authenticated application. Once these details have been captured and the parameters copied, our attacker will now try to trick the application by sending the false login details from their stolen list to the mobile web application over and over again in the hopes of finding a login match. However, this attempt too will fail thanks to our bot management protection. As our customer is using our mobile SDK to protect their mobile APIs, the mobile SDK generates a unique mobile token that identifies the device on the server side using encryption and tamper-proofing. Because of this, the attack is detected and therefore blocked as well. By now, our attacker has given up and moved their focus and attention toward easier websites to attack that aren't protected by Imperva and therefore don't require as much time and effort from their side.